challenges in terms of can do maybe some easy challenges, and we can go ahead and do maybe some complex challenges to maybe just familiarize ourselves with the PicoCTF. So from the last engagement we had, I was still basically giving up the recap we're going to have is majorly around how we're trying to define the importance of scaling up, the different platforms you can use for scaling up, what you can basically focus on when you're trying to grow your skill set and your technical arsenal, what sites are favorable for people who are just getting into cybersecurity, and also for people who want to challenge themselves into more complex challenges. And yeah, so today basically we're just continuing from where we ended last time. Last time we're basically going through an introduction of how basically you can use the PicoCTF for practicing, how you can be able to learn a few things on your own and basically challenge yourself. So today the platform we're majorly focusing on, given that we are preparing for the upcoming PicoCTF, I wanted to walk through a few challenges in different categories, and also maybe get a feel of how the Pico platform feels like. I just need someone to confirm if you can hear me. I don't want to be talking alone, so I really appreciate you. Okay, I think anyway I'll just continue. So so the platform basically has different types of events, challenges categorized differently in terms of web, crypto, reverse engineering, forensics, general skills, binary exploitation. So majorly when we talk about web, I don't know whether we're all familiar with web, or I have to break down basically how the web is basically set up. So if I'm, for example, just giving a highlight of web is basically how you look at implementation between, let me see if I can get So when we're talking about the web, we're basically looking at three things. You're looking at applications, you're looking at databases, you're looking at basically front-end and back-end systems in terms of web communication, HTTP, between the client and server, how those requests are processed. Then also you get to probably understand around session, how you implement sessions, because HTTP is stateless. So I don't expect us to be going through the basics of web, but basically just taking you around maybe a few challenges and how you basically go around them. If you're interested in maybe getting slides around your web challenges, maybe you could try Pwn College, or you could also try you could also try. Just give me a minute if my page is freezing up. You could also check on Pico Primer. Basically, Pico Primer is what gives you the different skills that you can basically learn on how to solve the PicoCTF challenge. So you can learn some shell. In this case, for example, when we come to web basically explain how you can implement your first HTML page, basically the code around implementation, understanding the structure of an HTML page. Basically, you have your header, title, and then the different headers. And basically, this is how you implement it, and this is how you can visualize it. So this basically is what you're looking at as what you look at as what's happening at your front end when you're importing different types of images or things like that. So for interaction at a front end level, at a client side level, we have of course JavaScript, and JavaScript gives it that extra ability to have dynamic queries basically running on your application, and basically that's its use. And most times you, of course, from a hacking point of view, you need to of course learn your JavaScript, because sometimes you have to craft payloads that interact with your backend, and basically an understanding of how you can use this maybe to send different forms, maybe XML based requests, fetch requests, different types, basically allow you to manipulate data in real time, and you can actually test what's happening in the backend. So it's one of the critical skills also you need when you're actually learning web exploitation. So this is basically just an overview. Here we can also learn, for example, we get to realize how JavaScript is implemented. It's normally implemented under the script block, and of course it has its syntax that is basically, as you can see within this document, we have an alert function here, basically that allows you to be able to send prompt that has the string basically that is within the alert function, as you can visualize here, basically telling us hello PicoCTF. So when you come to the PicoGym, there are different challenges. You can choose your web exploitation challenges and be able to, of course, go and understand. For example, you can choose the difficulty level, easy, and how basically you go about it is you get to have different things going on. For example, we can choose something that says web exploitation. Why does it? What basically you have your description of your challenge, and and a link to basically help you try to understand what's going on. So here it says, who doesn't love cookies? Try to figure out the best one for this thing. So we can open this URL. Basically, as you've seen here, we have about different users who have solved this. We have it coming up. So this is basically it's based off PicoCTF 2021. Category is web, and basically it's mapped as an easy challenge. And what you will do is, of course, you come, of course, to the platform. Try to research. I know a little point you need to understand. You need to be able to research to be able to sometimes solve these problems, because if someone else to like hold your hand the whole time, you definitely probably have a challenge. So on my browser, I personally have a cookie editor. Normally I always have it around to help me walk through any form of challenges and modify cookies in real time. So in this case, it's saying welcome to my cookie search page. See how I like different types of cookies. So you could just say, maybe just make a request, hello, says doesn't seem to have a valid cookie. Then you start, of course, try and interact. You try and interact with the application. You can look at basically at network level. You can see how the traffic is going on. For example, if you're making a request, you see, of course, you're not seeing any form of traffic here. So what you do, normally you could just try and say, okay, I want to interact with it. I want to see. Now you see when we pressed home, you see there's some form of request header here that's basically there's a URI that's added onto the thing, and we don't know how the structure of that request look like in this case. Now we can see from here, basically this is what you're seeing. So on your side, normally when you're interacting with for example cookies, in this case we have cookie editor basically, as you can see here, but they are basically your browser. Normally if you're using maybe say Google Chrome or the search, normally if you want to find your cookies, you find them definitely here under storage, and this is basically where you normally find cookies in this case. So if we're to refresh our page, when we go down to cookies, see what we have. We have something like a session cookie that's telling us it's a value number 1 -1, and basically That's what it's saying. So normally we have tools like Babsuit. You can use them to intercept, maybe understand what's happening. So we can power up Babsuit in this case. We can power up Babsuit. Babsuit gives us basically it's an interceptor that an interceptor that allows you to be able to basically capture your web requests between different things. So once you realize that you have Babsuit can help you capture packet, can help you capture the requests in real time. We have the proxy interceptor basically here, and the repeater where we can create different types of requests. So we can just try and intercept and go back to maybe our page again, try and set up a Foxy proxy, which is basically redirects your traffic to Babsuit. Then we can refresh, and in the process of refreshing, should be able to see our request here. Once we can configure, maybe say intercept the response because we want to see what's happening. Can forward. We basically still see our headers coming back. These are our response coming in, and keep forwarding packets. Then once we go back to our thing, we notice that we're still at the same page. So when you get curious about the challenge, you get to realize that okay, once I read this, I said there's something to do with the cookies. So you say, okay, for example, if in this case you have Babsuit, you can be able to interact with this request and manipulate them in different ways. In a scenario, for example, in this case, when you come to cookies, basically where we store our cookies, we see that there is a valid cookie and it has value 1. So out of curiosity, I can be like, okay, can I maybe try and manipulate this value? Maybe in this case, we can manipulate it from here. Can maybe set it to maybe 0, enter, and maybe try and just we can just maybe try and refresh. Can try and refresh our page and see what happens. In this case, you can see here we have cookies, so I can forward this request to my repeater. Then I start seeing, for example, what's the output I'm expecting. When I see here, it says there's a redirection. When we follow this, what do we see? This is a cookie, not very special though, right? So we start seeing, for example, okay, now there's a different response. When we try to render it, you can actually see that, okay, when we're manipulating this thing, it's saying this is a cookie, it's not very special though, and yet this time it's a different response. So we can actually send this even to, for example, in this case, since we're making string values, we can make the assumption that, for example, in this case, that maybe like we're just going to be manipulating this value. So we can make an assumption. We can go to intruder. From intruder, we can set up a payload point. Can clear all. We can just set this as our payload point, and then we can set up. We can choose a simple list. We can just say maybe numbers because can start from 0. Maybe let's just say to maybe say 20 to just maybe see. Just a minute. Set our payload. Simple list numbers. You can just say maybe say 20. In this case from 0, and then we can maybe say start. So basically what we're using here is the intruder bit of Babsuit, and as you can of course see, we start sending different requests. I don't know why it's too slow, but yeah, we can just wait and see what it's saying in this case. Give it some time. So we can see here down 20 to 21. Okay, so now we're seeing different requests, and now we start looking at different things. For example, response time, blah blah blah, things like that. So in other scenarios, an easy scenario where, of course, for example, you have the cookie jar, you can always just turn off your proxy. In this case, you can turn off your proxy, and you can go to your cookie editor. You could just maybe change the value. In this case, maybe say 1, and then you can save. Then you can refresh. This is how you basically manipulate cookies in real time to see, for example, when it's happening. So now you see here there is an endpoint that says check. It's basically checking for the cookie. In this case, I think you have the same response. So what we're trying to do here is manipulate the cookie. I don't know how far our intruder attack is going. Saying paused. It's quite slow, so you can go maybe manually, as you can see here. Okay. Go back to repeater. Remember we had 1. Can send our request. In this case, basically what we're trying to achieve, the same thing. Send our response forward. So we can enable following redirections to ensure that we avoid sending the request twice. So we can maybe try another value. In this case, we're manipulating basically just because it's just the parameter in this case that we're testing. So we can even go ahead 3. That's basically what's the same thing we're trying to achieve with the intruder, but we're having some interesting responses. So to configure something. Remote. Okay. So we get to realize that so we see now we're in 2017. Basically the same thing we're trying to show you here manually. Basically, when you repeat, trying to send different instructions basically by manipulating just this cookie parameter. So in this case, we see that we've this thing has run successfully. Can try and look at our responses. So we can look at our responses. In this case, we're looking at that is a cookie. So when you start looking at things, you start looking at differences. And for example, length, you're looking at things like different is length. So we're seeing that these are all almost in the 19,000, but we have some specific value here that is high. So when, for example, we look at this one, the difference in length, even the response time is different. We're able to see that, when we try and render, we're seeing that, there is actually a flag that is being shown here. And this is basically the flag that you're looking at. So we're able to manipulate the cookie parameter and actually come up with the flag, as you can see here. And this is basically what you're going to be submitting. So in basically a small summary, when you go back now, of course, like for example, Pico, and you submit your flag, you're able to see that, basically you've submitted your flag. And in this case, you have learned, for example, to understand that, when you get cookies, you've probably learned about cookie editor, called cookie editor, basically that it captures cookies for a specific session. You can use it to manipulate cookies, import cookies, even export cookies when you're doing, for example, session-based testing. So in this case, you're able to introduce that, I've been able to understand that cookies actually keep the session and they can be also abused. Then also, we can also maybe try something, for example, that says get ahead. Get ahead is a very interesting challenge. It's a very interesting challenge also under Pico. Basically when you're understanding, of course, for example, when you're coming to understand web, you get to realize that there are things that we call headers, basically, we call them basically like what you look at as we define them as methods. In this case, get, post, head, patch, all those different requests. So in this case, we are having basically a very simple dynamic website that basically once you inspect the source code, you get to realize that it has basically, it's as simple as it has two forms. Basically, this form that has index to PHP with a post that chooses blue, and then one that chooses red. So in this case, you get to realize that if we are again to send our traffic to Bob, in this case, let's first just close the sector, set off. Once we start browsing through this, basically we get to see, for example, in this case, that just give me a minute, guys. Just need to shut my door, if you don't mind. Okay, so when you, for example, have when you're setting up, when you're understanding basically how websites work or platforms, you need to, of course, the first thing we remember to talk about was the importance of understanding the different. For example, in web-based sessions, you're looking at do I need to understand how to interact with a specific, if I'm interacting with an application, what methods do I need to know? Because most times when you're looking at web, we forget about the basics basically as we look at, and these just basically help you understand. For example, you need to understand how web applications work, and these are very easy challenges, of course, and they always, of course, test basically your fundamentals in terms of, do you know how methods work, do you know how, for example, you craft a payload. And in this case, because we're using the Pico platform, we just have to use the challenges. You can actually just use your browser, and also you can also come ahead and use maybe Cal. In this case, you can also use Cal to interact from your terminal. In this case, you can also use Cal to basically interact with that URL, and basically you can, of course, find the same output. But the beauty about like having a command line tool like Cal is your basic your ability to actually craft the payloads. Just a minute. Okay, still have a response. Okay, so with these tools, when you get, for example, in this case, this challenge that we're basically looking at, we get to realize that, okay, I have, for example, this, when I say choose red, basically it runs, there's a PHP script that runs, and basically the thing turns red. When I choose blue, it's basically the same thing. And you get to realize that, okay, when you look at your targets, you've been able to map that thing, it's port 61, and just add it on your scope. And then we can actually start maybe observing, for example, by just looking at, okay, can we send this to the repeater? Can we test the different, for example, when we send a get request, what response do we get? When we set, maybe say, we can say maybe a patch method, what do we get? How does basically our thing respond? You can also choose maybe head in this case, and you see that for this case, basically the challenge basically just talked about, can you get ahead? And get ahead, basically you're looking at, okay, I'm going to manipulate the method basically to head, and you see that, of course, on the server response there is a flag that you're seeing here, and this is how you basically approach this flag, this specific challenge. In this of course, in this submission, basically what are you learning? This is basically teaching you about the importance of understanding that, of course, there are different methods that build the structure of a web request, And of course, there are also different things that you need to pay attention to. If you're looking at, for example, from a recon point of view, when you're doing an assessment, you get to realize that, for example, when you sometimes make requests to specific websites and different applications, the server response is very important, because this basically gives you knowledge of what is happening at the server side. And these headers can be very critical. For example, you can have the set cookie header that basically can be used to hold a session. In this case, if it's session-based cookie, and these are things that help you basically ensure that, for example, if you interact with an application over time, it's basically turns into a stateful interaction because of the set cookie that is implemented on the server side. So this is basically what, in this case, you get to learn. And I would always recommend that before you actually go and approach these web-based challenges, you go, of course, to the Pico Primer, look at a different category, try and read about it, try and interact with it, and there, of course, you get to understand the difference in terms of how you can approach it. And there are quite a number of challenges that you can pick out. I decided to pick for you a few small ones that basically you can pick up on. Then also we have, of course, another interacting category. For example, in this case, we have cryptography, and with cryptography, basically, cryptography comes in a way that we get to realize that, okay, cryptography is implemented in different ways. There are books that I can recommend. There's a network-based, I think it's an advanced book, but it's a network-based network security and cryptography book. I think I'll share it on the group. It basically looks at helping you understand some of the way the different types of cryptography and how they're basically implemented. Basically, there are known techniques that you probably need to know when you're basically starting out. For example, you need to understand about XOR, how it works, modulo, as you can see here. And these are, of course, things that for example, can try an example and go about it. So in this case, they say cryptography can be so easy. How do you know what route 13 is? So route 13 is basically, if you're to say, okay, for example, I need to solve this, you basically, from a CTF point of view, you just have to pick this, then you ask yourself, what exactly is route 13? So if you're to come, for example, to Google and ask about route 13, in this case, as you can see here, route 13, if you ask yourself what route 13, it's just basically a substitution cipher, as you can see. And it does basically an inversion by just push it. It does a rotation of 13 characters. And we have different tools that you can use. We have decode, that is basically used, decode FR. We have CyberCTF, that is another one that is quite good. My internet is acting up, so yeah, you guys will forgive me. So in this case, we have like decode FR, and basically you have you input something here, basically your ciphertext in this case, and then you request, of course, for a route decryption, a route 13 decryption. And you can see that, for example, in this case, basically there was a jumbo up, but you can see that you have an output basically here that gives you the flag in this case. So you go first, go to, of course, the Pico Primer. You get to interact with the different cryptographic challenges, and of course you get to, of course, as you do them, if you always have a challenge, you can always reach out. Then, of course, we also have like reverse engineering challenges. These ones can have maybe increase also maybe a difficulty level. So we have also this basically at the same way. Then we, of course, have our easy challenges. When you look at, for example, transformation, it's a very, very easy reverse engineering challenge. Here, basically, it's like, this is basically just Python code. It asks, I wonder what this really is. So I think this is a file that we download. In this case, it's called ENC. Basically, I think it has ciphertext. And then we have, for example, something that talks about this. So basically, this, for example, I can just see that this is Python, blah 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 blah. So we have character. In this case, we have this bitwise shift, and yeah. So we can maybe just try and build a script and maybe give some understanding of what's happening. So in reverse engineering challenges, basically, PicoCTF. So we remove our file. So this is basically what we are getting in this case. So if we say equals open, basically we have enc, can say it's just, so we have enc. If we are to compare, we have 19, basically this is 19 characters, and if we just say let's try and find out what each character is in terms of values. So we say here, we look at basically what we're looking at. So this is our ciphertext, the one that we have found, which is A in this case, and we have basically something like this, that this is basically what happens. So whatever is here is basically a join of just this very easy. I don't know whether we're all very familiar with Python, but of course what happened here is we had our value, we had our flag in this case, and we had a bitwise shift, left shift. For example, if I have maybe say this basically gives us the value equivalent. For example, if I have maybe say A, let me say Z equals help. In this case, Z is basically just a declaration of something like maybe like like that. So if I wanted to convert, if I say maybe Z, in this case 1, I'm basically getting the equivalent in terms of values. And if I was to say, for example, I shift this thing left, in this case, binary shift it left, basically I'm getting, this is now the value that I'm basically getting in this case. So what basically this does is, if we are to look at a binary equivalent of, if we are to look at this in this case, as you're saying, and then we are also looking at maybe say a binary equivalent of this. You see now, this is the shift, this is the leftwise shift in this case. You see, 1, 2, 3, 4, 5, 6, 7, 8. So basically what this shift means is that there is going to be a shift. It's artists, and what is the different character and odd? Character does, they're inversely proportional. Basically, character converts basically decimal equivalents into letters, what you understand as the alphabet. For example, if I had character in this case 101, I would get my E, which is basically the same value here. So odd is basically the opposite of this. This one takes in strings, this one takes in integers. So going back to just explain this, so whatever value in this case is shifted 8 times, shifted 8, and then there is an equivalent addition of there's an equivalent addition of in this case the next value. This is the next value, yeah. So this does your bitwise shift, in this case to the left, and then this adds the value of, then it goes and adds the next value. So, and then we're looking at a step of 2 for the length of this. So basically what means, if for example I have for every character in this case, we shall be subtracting first of all this value, you get. So when you do for example a shift, in this case the shift of 8, if you realize that you're going to be giving, for example, this all means all these values are going to be 0. Yes, because first of all these are 8 values, and however many values you add here, once you remove this 8, for example, if I have, when I look at for example odd, in this case of A, let's do this. We have just God forgive my eyes, guys. In this case the 1, in this case 1, let's start with 0. The first value is 0. We have this, yeah. But if we are to say, let's get the binary equivalent of this, yeah, to be able to give maybe some clarity on how we go about this transformation, we get to realize that here, if we're to count the first, if we're to count the 8 things here, basically, if we're to do a shift in this case, this is basically an addition of 2 values. If you from this thing, you're looking at this, you first shift, then you add this. So in this case, what you're adding here, this, if you look at it, if you remove the first 8, the last 8, you're going to be getting the value of, in this case, the value of the second character of flag, if you realize here. So if I'm saying for I in the range of the length of flags, step 2, we're looking at the first, in this case, if we're looking at help, for example, if we're looking at, let's use a test and say, for example, dummy flag. Let's call this a flag. It's a dummy flag. Is equals to, in this case, I am a noob. I'm a newbie. Yeah, that is your dummy flag. If in this case, for example, you say you want to find out, in this case, you can also call this maybe a dummy cipher. In this case, dummy cipher. In this case, it's going to be this, for which we're introducing the length of dummy flag. I hope dummy flag is in 2. Guys, I hope we're understanding each other, right? I don't want to sound like, basically, like I don't know what I'm saying, but yeah. So if we are looking at dummy flag in this case, which is, I hope it's this, in the length of 2, just to make work easy for everyone. Yeah. So it's out of range. Let's say dummy flag, it's 11 as I was fearing. So nobies. Yeah, I'm a nobies. Let's just give it, in this case, that, right? Then we go again. So if we're to look at our dummy cipher in this case, you see, we have done a conversion. So now when we look at, for example, the length of dummy cipher, it's basically 6 values, yeah. But you get to realize that now, from 12 here, as you see, from the length of 12, we have cut them to 6. So for every single value, in this case, that is happening, this transformation basically does that. It picks the last 8. It picks when this shift is done to 8 bits. basically it picks the last 8. The last 8 should be equivalent to this value, and then this other one, once we push it back 8 bits, should be giving us the value of this. Does that make any sense? So in this case, from our A, let's see, do you still have our A? Just length of A. Remember now, length of A is giving us 19. That means the length of our flag is probably going to be times 219, basically, which should be giving us I don't know, 19 times 2, 38 characters. So we can go ahead and maybe just I can give you maybe just a snippet. Maybe we can just try and show. Let me create the first characters in this case. So if we have, for example, our value, this one, this is remember how we had talked about the first. Let's just try and do a conversion of the first value. We have A0. When we do a binary of A0, we have basically this value. Yes. If we were to do a right shift, we shall be removing these values in this case, as you can see here. We shall be removing, for example, let me just show you. If we were to do a right shift in this case, integer and string, just a minute. Before I string it, yeah, so we do the shift before. Before I make, okay, so you see now basically this does, it cuts away what we are looking at in this case. Does that make any sense, guys? Yeah, does that make any sense? Okay, so now let me show you something very interesting. So now if I'm, for example, if I want if I'm giving Snowden Karibu. So for example, if let's call this first thing A. I just want to give you guys some 101s here. Let's call this maybe say X, because we used to learn about X and Y. Let's call this X, right? And then let's call Y our shift, right? In this case, guys, I'm sorry if this is boring. It's probably like just a math class. Looks like a math class anyway. So so in this case, if I have maybe say my Y being this shift, right, the one that we're talking about. So we have our Y in this case, and we have our basically our X in this case, right? So there's something that we look at. If we are to say, for example, it gives you that value in this case. So if you have your Y in this case, yes, if you have your Y, once you have, for example, your value of your X, and then once you shift this, once you left shift this out, yeah, this value here is going to be, this Y here is going to be this first character, in this case the first character of your flag, this one that is going to be shifted, because when we shift it back, we're going to get this value, right? So in a scenario, for example, where we're looking at the first character of A in this source, the first character of A, the one that we're looking at as at A0, this one, yeah, once we do this conversion, push it to, in this case, right shift it by 8 in this case, and then find the character conversion of this value, that the 112, we get a P, remember, which is supposed to be which is of course our flag syntax, as you can see here, Pico. So in this case, we shift how should I explain this? We shift for the first character. We're going to shift the 8 to this, And then we shall have this value representing our P, and we change it to a character. Now, with XOR, remember, if for example, if I have, in this case, if I XOR this value, if I pipe this back to the zeros in this case, because now my Y, which is this value here, right? In this case, this is my Y. When I XOR my Y with when I XOR my Y before the shift with this X, I basically get this value. So if I have my X in this case as X like this, let's say X in binary like this, and I want to basically remove these values, right? It will be basically the equivalent of me XORing Y with this case with the leftward shift. Y covered area, you get, which is basically this value, the 0 0. In this case, had to remove this. And if we were to say, for example, in this case we get character, I don't know whether there's so many problems to do with the curly brackets, object string, just basically a typing conversion. So if I have my X, I find I could actually just remove the binary equivalent, because I was just trying to use that to explain the basic substitution. If I did this in this case, and removed these curly brackets, we have our 105. And if we are to, in this case, find what 105 is, basically we are seeing it's Pico. So in this now, we have noted that, okay, we are able to find that for the value in this case, our Y is giving us this, then we're looking at, so we get the value of our Y, we do a shift in this case, and we find our next character. So let us just write a transformation to just be able to give that explanation. I hope the explanation has made some sense, so that maybe as I'm writing, we can be able to pick it up. So in this case, A, remember, is this. So we can just say, let's say in this case we want to join, we are going to do character conversion over, we're going to look at, now we're going to pick one single letter. In this case, we're going to pick the ordinary value, okay, which is going to be our first character, up into our second character, add it, for 1, for 2, this is plus in this case, yeah. So we look at just writing a simple one in this case. So if I'm to say, in this case, let's say you can just maybe first change A, just change A into maybe say just what, at least for I in A, be the depend, in this case we get actually we need to just add B in this case. Okay, we're basically just creating our list. So B is basically made up of those different numbers, as you can see. So this is basically an equivalent of the Pico, basically the P and I, this is the C and U, blah blah blah. So we can just try and now write basically if this now makes any sense. The easiest way now would be, for example, now we pick this value Remember now, this value is a value that has both the A and basically the X and Y, right? Then if you remember, so remember this has our X and Y. Once we shift this to the right, we get our Y, right? We get our Y in this case. Does that make sense? So we have our first value, the X in this case, which is this is your X, right? So you pick this value, shift it 8, you have the first character. Pick this value, pick in this case, pick the character that you have shifted. In this case, look at the character from the previous thing, shift it back to the left, and then XOR it with this value, and you basically have your equivalent in this case. So basically you're nulling all these values to get your first character. Then you change all these last 8 bits to 0. You find your first character, in this case the P. Then once you remove the other 8 characters, basically you find the what? You find the second letter. So this is basically what you're going to do for all the different what? For all these different for this list in this case that we basically have. So how do we now go about it? So remember, now we have found out that we can what? We have been able to understand in this case. We have now in this case our string, which is our B. So now we have to find out that for every single for this transformation, how do we go about solving the issue? So we can write a script. So in this case, so we can say maybe for I in range, let's just say here, let's see, because that's where we're going to put our final flag. So for I in range 0, and just put length, okay. Let's confirm for I in range A. Now, the first thing, remember, we're going to do, we're going to get this. We're going to first add our first. We're going to get our sum, in this case, our first character. If you want, I can actually just show you a very interesting concept. So the first thing is, let's first do the C. So we first want to add our C. How do we add our C? Basically, remember our X in this case. Our value here, to get the first value that we're going to add, in this case we put C, and in this case we're looking at should we set the character equivalent, because we want to maybe introduce a character in this case. So we're looking at, in this case, I in range, I made a mistake here, remember. So yeah, stop wasting time. For I and B, for I and B, which is basically our value, in this case I. So we can see the append. First thing we're adding is we're picking up the character. In this case, we're adding the ordinary value. So we're first adding our first value, the P, which is basically this value, which is our I in this case. I in this case shifted to 8. Just want to confirm that. Just allow me. This is just a test, just to show something, just a concept. Let's see. Okay, so you can see here we've just basically, this is just a dummy test. So you can see that we have from our script here, we can see that, for example, for all the letters that we are skipping, in this case for the PicoCTF, we have basically we have a value. So we need to now add our second value, which is basically our which is our next value in this case. So in this case, we have implemented the first character for all the single things. So now we are going to implement this, which was basically what we're looking at as what we're looking at it as our y in this case, and our y basically looked at picking in this case what we have as our what we're looking at as this value. You get shift it to in this case we're looking at this value that we have, yeah, XOR with our y, our what, we're looking at our x value. Yes, the x value in this case we're looking at eliminating all the eight characters basically that are on the strong side of this. With registers, you would probably look at this as if it was a full register, you'd be like, I'm going to remove this from maybe say array from EAX to just basically AX, and you'll be best looking at this binary, which is a very interesting concept when you're looking at reverse engineering. So in this case, we go back to, we have been able to see that we are able to achieve. Now we need to find out what our second character is. Our second character is basically just the lower level bits of this specific string in this case. So what do we look at? We're looking at one, being able to understand how to null whatever we have basically on this other side. So this is our initial value, but with zeros, if that makes any sense, with zeros, yeah. So once that means basically we come to our character, then we're looking at, okay, we are getting our I in this case, but we want to look at it, we want to XOR it with, this is basically a shift to a shift. This is a shift, the shift we are looking at in this case, and then our shift back, right? Just a minute, did I do wrong here? So we have not yet nullified our thing. Let me just make C empty again. Our C is not. Once we run this, you see now we're able to get our equivalent. So once we're able to combine this, in this case, we're able to see that we're able to get an output in this case of basically of our flag in this case, as you can see here. So with this, basically you just showed okay, for example, that okay, you've been able to understand a syntax of a phrase, and you've been able to work it backwards, and able to what? How from a 101 perspective, of course, as I said, when you're still learning, of course, the fundamentals, one of the things you get to realize, you need to be able to understand, for example, have some bit of Python, have some understanding of how basically how different operations affect different operations, basically how they affect how you implement different logic operators in this case, and or XOR, modulo, all those are very important, and you still find them, of course, under the Pico primer. So that's maybe something also probably you need to understand, and basically how I would introduce maybe reverse engineering. So the other things you could also pick up, the other topics you can also look at, also maybe some how different technologies work. Maybe you can be able to read, like this is maybe like, for example, this is a Python script run to get the flag in this case. So this is apparently a Python script, so I think we can download it here. I don't know what it's about, but I like to just play around and believe that I hope this was informative, legally from the side of when we say run script, just saying it has the flag already, so you can just make it executable in this case. Run me, then you can run me, and then basically it's just a sanity test. This is just general skills, maybe just trying to test how you can run flags. So it's quite a very open challenge. So basically that's the gist around starting out with the Pico. So the Pico gym gives you different challenges. You're able to test. You're able to you could also go and learn about some binary exploitation, teaching you about format strings, heap. These are more advanced topics, but of course it's always good to of course understand exactly how is something done, how is it implemented, and all those things. So for starters, if you're looking at going to understand this, most of this is already implemented in this area. As you can see, there's some, for example, if you're looking at binary exploitation, there are some scripts that you can write just and help you understand, for example, things that we just explained, for example, and XOR, how the logic works. These are things that are good for you to understand from a programming point of view, because they solidify your knowledge around maybe the basic concepts on how, of course, computers process information and how you can, of course, be able to manipulate them as you go down to learn things like, for example, assembly in this case. And this is now where, of course, now you start understanding the importance of how you can convert this into assembler, and how these different instructions and registers can be mapped to what you look at as a C equivalent to a program. So, for example, you can have this printf function that takes in different parameters, or open that takes about 3 parameters. That is the file descriptor, of course, your buffer, in this case, what your info, and then of course the length of that file in this case. You find that all those are implemented in assembler using the different registers, and those are things you'll of course get to learn as you spend more time, as we of course get involved more in the classes. Remember, guys, PicoCTF is a very introductory CTF, and it basically tries to build your skill sets all the way from zero to nothing. So you can always feel free to reach out via the group to join, and also of course use the Pico primer to at least help you learn and how best you can use the platform. These are all just basic challenges, but of course we expect you to get down to business, try and do as many as you can, as of course as you prepare for the upcoming PicoCTF challenge. So with that, I want to summarize. I don't know if there are any questions. It was a very basic session. I know so many people left because they are really good at what they're doing. So we of course wanted to use it at least to familiarize before we actually start on going into more detailed topics. So ideally, we shall be going to start focus on this, on actually more advanced stuff in terms of, for example, if we're going to go web, we're going to start from Web 101. You're looking at client side attacks. Then you look at, for example, server side attacks. Then, of course, you also look at things to do with, for example, APIs and the likes. And of course, as we get more information and feedback from you, we can always customize the trainings into more hands-on training. So with that, I want to open the floor for any questions, and I'm looking forward to sharing and also, of course, hearing from you guys. Over to you, Joel. Okay, guys, do you have any questions? Do you have any inquiries? Anything anyone wants to share before we proceed and say, okay, everything is okay, and wish everyone a good Friday. guys, thanks for giving us your time. I appreciate your feedback, and definitely looking forward to more time with you guys. Have a good day.